the Makerspace Answer Battle, everybody. I'm your host, Alex Edwards, and boy, do we have a good one for you today. Let's get it started. Round 1. Top 7 answers are on the board, and we asked several educational researchers, name a vital element of a makerspace definition. Team 1? Yes, space. You need a dedicated space or a destination devoted to the activity. That space could be physical or virtual. It could be a permanent space, or it could be a temporary space that's used for other things at a different time, but you need a space. Materials and tools, yes, absolutely, provided for the students to explore and use in that space. For them to begin problem solving, great. They're going to be using those materials in that space to explore in a non-stressful, low-stakes way, entering into that problem solving loop. In order to produce something, and remember that product could be physical, it could be expanded brain capacity, additional knowledge, brain growth. Learning could be formal or informal. Yes, it could be tied to a learning objective, it could be curricular, or it could be an informal, exploratory kind of learning. The learner is in the lead, where the learner now is transformed from the consumer of information to the creator of it. And clearing the board, yes, collaborative activities. Activities are engaging and students are encouraged to collaborate with one another and to communicate as they problem solve. So all those points go to Team 1. Great job. And we're going to keep it moving to round 2. In round 2, the top 4 answers are on the board. We referenced Loisher, Preddy, and Derry. Name one of these steps in the UTech model for implementing makerspaces. Yes, Team 2, that U is for using, where students are encouraged to explore and enjoy something that was created by somebody else, something like Legos or Lincoln Logs. They're just using, exploring. Absolutely, that T is for tinkering, beginning to research, question, trying to find a better way. That E is for experimenting, where they begin to build and test their theories, modify things. They're learning from their failures. And that C is for creating, that highest level where they're going to produce their own novel product. Excellent. So those points go to Team 2. And we keep it moving to round 3. Top 7 answers are on the board. We surveyed educators across the country. Name a benefit of using makerspaces. Team 1, critical thinking, absolutely. Brain growth as a result of critical thinking. When both hemispheres of the brain are stimulated, the brain grows. And as an added benefit, anxiety is reduced. Awesome. Creativity, which goes right along with that critical thinking. Thinking about those levels of Bloom's, creativity is the highest level of Bloom's, and it is part of that critical thinking process, kind of the pinnacle of it. Communication and collaboration is another benefit. One of our 5 C's, those things that employers are looking for, and that is sometimes lacking in students, but that makerspaces can really bring out in students. Citizenship, another one of our 5 C's, teaching kids how to work together and how to respect each other and how communities thrive as they work together to solve problems. That's STEAM alignment, putting that art, that A in STEAM, making it more palatable and more low stakes for kids. A growth mindset, generating a growth mindset in students so that they learn that failure is a part of life, it's expected, and we can definitely learn from it and fail forward. And it can connect to the curriculum. It's another way to strengthen what we're doing in our classrooms and what we're teaching already, or it could also stand alone on its own. It doesn't have to connect to our curriculum. Great job. So all of that is going to Team 1. Excellent. 4 answers are on the board. We reference page 25 of our textbook. Name a reason that the library is an ideal space for housing maker spaces. It's the biggest classroom in the entire school. Absolutely. So it's a big space. So there's room for kids to move around and to house all those materials. And it's the hub of the school, the center of the school, where we might already have interests being drawn. It already houses knowledge and materials. It's known as a place where kids can access a lot of information. So that makes sense. It also aligns with AASL Learning for Life initiative standards, which are think, create, share, and grow. And it's sort of a natural progression. We think of the library as a place where we go to retrieve information, and so it makes sense that it's a natural progression of things that it would be a place that we now go to create new knowledge and new information for ourselves, new understandings. Absolutely. Those points all going to team 2. Keep it moving to round 5. Top 8 answers on the board this time. Referencing pages 32 and 33 of the textbook, name something you might consider when selecting a location for a makerspace. What might you consider? Ooh, flexibility of furniture. Is it easy to move? Can kids sit there and stand there? Is it able to be flexible? Visibility. How are you going to pull people in and inspire people to want to come and join your makerspace? Can people see it? Can you advertise it a little bit in its placement? Access to materials. Are kids able to access things in order to research their problems as they're coming up with them, to brainstorm, whiteboards and things like that? Do they have access to those materials? Can you provide access to those materials? Do you also have access to internet and electricity? Where are your outlets located? Yes. Length of use. Is this going to be a fixed station? Is this going to be a rotating station? Can it stay out all day? Or is this something you're going to have to pick up if you put it there? A variety of grouping. Is this going to be for just individuals to work at or groups? Do you have collaborative spaces as well? Storage of materials. Do you have a place where you can store your consumable materials, things that might need to stick around for a while in between different groups coming in? Or if kids don't finish their projects, do you have a place for their works in progress? Where are you going to store those things, maybe nearby that makerspace? And then ease of cleaning. Excellent. Can you clean the floor around it pretty easily? Do you have access to a sink? Those sorts of things if you're going to do messy projects. All right, so team 2. We keep them moving to round 6. Top 6 answers are on the board. We reference Dr. Kwan's experiences. Name a low-cost material you could use to get your feet wet if you're just getting started with maker spaces. A low-cost material. Recyclables. These are the things you might throw out anyway. Things like paper towel rolls, food boxes, newspaper. Absolutely. Puzzles. There's so many puzzles you could pull from. Puzzles just out of a box. You could do Rubik's Cubes, which are puzzles. You could do Sudoku, crossword puzzles, all kinds of low-cost puzzles. Absolutely. Board games. Lots of board games. The kids don't always get a chance to play these board games. And you could expose them to some new board games. Lots of critical thinking happens in board games. Craft supplies. A lot can just be done with paper and regular coloring supplies. Painting, drawing, coloring, origami sorts of activities can be done with just plain old craft supplies. That good standby Legos, can't go wrong with those. Kids of all ages love them. And whiteboards. Who doesn't love a whiteboard? A lot of things can be done with whiteboards, from brainstorming, all different kinds of activities. Great. All right. Team 1 gets those. And we're going to head into our final round. Round 7. Top 10 answers on the board for this one. We referenced answers given by LMNet users. Name additional materials that you could use to include in a makerspace. Building items, things like Tinker Toys, Marble Runs, Lincoln Logs. So again, these pre-packaged, pre-made items that kids could use to build all sorts of things. iPads with a variety of apps. I mentioned green screen apps, but there are a variety of learning apps that you could tie into whatever curricular need you wanted to. Sewing, crochet, looms, knitting, all of those kinds of fabric and yarn related items. Robots, lots of little small robots, B-bots, Ozobots, all kinds of things robot related. A 3D printer and pens, getting a little bit more expensive as we move up this list. Pre-made kits, such as makey kits, STEM kits, little bits, or snap circuits. All kinds of pre-made kits that kind of take a little bit of that work out of collecting all of the items for you. Jewelry making supplies get a lot of attention in my classroom anyway. Wood and tools was a fun one. Puppets and puppet theater, so giving those kids a chance to act things out. And then a duct tape station was another idea. All right, so going into our final scores, we have Team 1 with 1,530 points and Team 2 with 2,300 points. And that's a wrap for our special Makerspaces edition of Answer Battle Classroom Viewed. I hope you learned something and had some fun. I know I did. Thanks, guys.